All right, guys, we wanted to speed things up a little bit by going over the homework in a video. So I'm going to run through these 8 examples in quadratic equations. So first up, we have x squared minus 36 equals 0. And all of these, you'll notice, are set up to equal 0. If I wanted to be meaner, I could have made you solve them to get equal to 0. But our basic step when we have a quadratic equation is to set it equal to 0. So this first one's one that we could add 36 to both sides and try to then square root and take the square root method, but we're going to focus on factoring as our primary method to solve these 8 problems. This is a difference of squares, so we have x minus 6 and x plus 6. And since they equal to 0, when we have 2 products, 2 factors that are multiplied together to give us 0, what that means we're going to do is we're going to go ahead and set each of them equal to 0. So what would we plug in for x to get 0? There would be 6, and there would be negative 6. So our solution set is 6, negative 6, 6, negative 6. When we look at our second example, this is a trinomial, so we can't take that difference of squares. There's no GCF. There's nothing we can take out of everything when we look at the numbers, but there is a GCF that is a variable. So we can take an x out of all 3 terms, and that's going to stay there. Don't erase that x. Just take it out and leave it on the outside. Now this trinomial has a lead coefficient of 1, a equals 1. So we're looking for 2 numbers that multiply to give us this number, negative 7, and add to give us negative 6. And we're going to bring down that x. Don't forget that x. Now we end up with 3 factors, each one equal to 0, and that gives us our solution set of 0, 7, and negative 1. Because the x equals 0, x minus 7 equals 0, and x plus 1 equals 0. I'm going to jump up here. This one is a binomial, but it doesn't look like I can square root both of them. I can actually take out a GCF. I'm going to do that. And I'm going to take out the 7x, leaves me with x minus 2 equals 0. And so if I set each of those equal to 0, I end up with a solution set of 0 and 2. Remember, just because they are 2 numbers in brackets, that doesn't mean they're an ordered pair. Those are 2 x's, not an x and a y. D has no GCF, nothing we can take out, but what we can see is that we have a lead coefficient that we're going to want to multiply. The method we talk about in Algebra 1 is slide and divide. There's another method where we split the middle term. So what we're going to do is we're going to split the middle term, but either way, we have to go ahead and multiply those 2 together. And so what we end up with is negative 18 is what we're looking for the product. The sum is going to be that 7 in the middle. So what are 2 numbers that have a product of negative 18 and a sum of 7? Now our giveaway here is that if they sum to a positive number and they have a product of a negative, that means that they're going to be a negative and a positive, and the positive number is going to be more powerful. It's going to overpower the negative. So let's try this. We're going to say 18 and negative 1. That works there, but it does not work there. 9 and negative 2, and that works for both of them. So what we're going to do, instead of the slide and divide method, which we talk about in Algebra 1, we're going to do the split middle term. So we're going to take the middle term, and we're going to split it into 2 separate terms, 9x minus 2x. What we say is 7x is equivalent to 9x minus 2x. It's like saying the same thing. I'm just substituting 9x minus 2x for 7x. So what I can then do is I can pull out the 6x squared and pull down the 3, just pull those down. And now I can factor this using grouping by factoring the first set and the second set. The first pair has a GCF of 3x, that leaves me with 2x plus 3. And the second one has a GCF of negative 1, x plus 3. And so my 2 factors are 3x minus 1 and 2x plus 3. That equals 0. I'm going to go ahead and solve each of those by setting 3x minus 1 equals 0, adding 1. 3x equals 1, so x equals 1/3. That's one solution, but I also have to set the second factor. And so I end up with my two factors. My solution set for this one then becomes 1/3 and -3/2. Let's jump on these last four. That's about as complicated as it gets. So let's see why they're in this order, because we have some progression here. This looks, on this side, this looks like it's going to be a lot more difficult because it's got big numbers, but we can actually take a GCF out of everything. So we're going to do that. If I take a 3 out of everything, that gives me 3. And then I'm going to put a 1 in front of that x because it has a coefficient of 1, just because we say plus x, it's plus 1x. And then we're looking for two numbers that multiply to -12 and add to 1, so it's a +4 and a -3. And that gives me a solution set of -4 and 3. Next up, we're going to jump over here. There is a GCF that'll make this a little bit smaller. And if I take out a 2 out of both of these, I end up with 2 and then 16x squared minus 1. This is a binomial, not a trinomial, so I got to ask myself, now that I have taken out the greatest common factor, is there some special case? In other words, is this a difference of squares, difference of cubes, or sum of cubes? And in this case, I can square root both of these, so I get 2, and then 4x minus 1, 4x plus 1. And then it's still equal to 0, so I'm going to set each of my factors equal to 0. Notice 2 is not really a factor, it is, but when does 2 equal 0? Never. So unlike these, which are variable, I can plug in an x that'll make that 0. No matter what I try to plug in for x, it's not going to change the 2 to be a 0. So that's going to end up being a solution set of 1/4 and -1/4. Let's jump over here on this one. This one has 4 terms, so we're going to go ahead and look at it like it's got 4 terms. We're going to look at the first 2 and the last 2. We're going to take out what we can, our lead coefficient. What can we take out of these 2? And that's going to be x squared, x minus 2, -9, x minus 2. Now, grouping those that way leads me to 2 factors, but it started with a 3rd degree, which means there's probably going to be a way we can split up, hopefully, this. And if we take a look at this factor, it's got a 2nd degree, so it could be further factored if one of our rules applies. And so the rule applies as difference of squares. And that gives us a solution set of 3, -3, and 2. Almost done. We're going to do this one last one. Leading 2, leading 2. What can we take out of both of those? Again, x squared. Now, in this case, this x squared plus 6 is not a difference of squares. It's not a sum of cubes. There's nothing I can do. So this ends up being my final factored form, but I still need to write my solutions. My solutions end up being x squared plus 6 equals 0. And this one's x minus 3 equals 0. So this is obviously going to be x equals 3. But this one, when I subtract 6 I get x squared equals negative 6. So what would I plug in for x squared to get negative 6? Well, let's try to square root it. If we square root both sides, we end up with, we end up with an imaginary number. This ends up being ugly, ugly, ugly. It's ugly because we have a negative underneath our square root, which is not something that we wanted. So this actually ends up being extraneous solutions, and we're going to see those when we talk about the quadratic formula here in a minute.